Okay, can go. Can start.
Hello everyone, my name is Nadir and I am an assistant lecturer at University of Algiers 2. This is the presentation of my final project for AI Foundation at the Limitless Learning Program with my colleague Houssam.
Hello, everybody. My name is Houssam Shagran. I am a network and software engineer, and I work as a head of production unit in Sonar Gas Group. In this presentation, we will talk about the data set of Titanic. It is our final project in Limitless Learning AI Foundation to training.
Welcome to our AI Foundation final project presentation on supervised learning, where our goal was to build predictive model on an open source data set and present our findings in a concise 5-minute talk. We chose the Titanic dataset to predict passenger survival and to explore which factor most influenced outcomes, aligning with the assignment's focus on data exploration, pre-processing, model training, and evaluation.
The Titanic dataset contains 891 passenger entries across 12 variables. We survived and as the binary target, where 0 indicates deceased and 1 indicates survived. Key descriptive statistics include an average age near 29.7 with standard deviation around 14.5 and an overall survival rate of about 38.4%, which frames both the demographic profile and the class imbalance we needed to consider. We addressed missing values by imputing age with the median to handle outliers robustly, imputing embarked with the mode due to only 2 missing entries, and dropping cabin because over 77% of its values were missing. We engineered family size using the formula sub-SP plus parsh plus 1 to capture total family presence. Then one hot encoded categorical variables like sex and embarked and removed identifiers such as name, ticket, and passenger ID.
We split the data into train and test sets at 80 to 20 with random state of 42 to ensure reproducibility, and standardized numeric feature using standard scalar to improve the performance of distance-based algorithms such as KNN. The process follows common syntax to train test split and model fitting like K-neighbor classifier with fit and predict, as summarized in our supervised learning notes on splitting and KNN usage.
We compare 3 baseline models: logistic regression for interpretable linear classifier, a decision tree for nonlinear relationships and feature importance, and k nearest neighbors as distance-based method sensitive to scaling. Canon operates by computing distances to training samples, selecting the k nearest neighbors, and assigning the majority class, which makes proper feature scaling essential for meaningful neighborhood comparisons. Our performance comparison showed KNN achieving an accuracy of 0.8156 with precision of 0.8060, closely followed by logistic regression at 0.8101 accuracy, while decision tree reached 0.7821 accuracy. A representative confusion matrix for the best Cannon model included 92 true negatives, 54 true positives, 20 false positives, and 30 false negatives, illustrating a balanced trade-off with strong overall correctness and solid precision. Decision tree feature importance highlighted sex female and Rowley 31%, fair at about 23.7%, age near 21.8%, P class around 11.3%, and family size near 6.6%, confirming the dominant role of gender and socioeconomic status. These findings align with historical context and the Women and Children First policy, showing that gender, wealth indicators, and age were key determinants of survival in this dataset.
On the implementation side, my work was in Google Colab, beginning with structured data ingress and environment setup, such as using the Colab upload widget to bring the dataset into the notebook. I organized the training workflow into a clean model dictionary, trained logistic regression, decision tree, and KNN, and computed accuracy, precision, recall, and F1 on the test split in a repeatable loop to ensure consistent evaluation across models. I also extracted decision tree feature importance to interpret which variable drove predictions, and prepared outputs that fed directly into the slide highlighting EDA, preprocessing, and key results.
My focus was synthesizing the exploratory analysis, pre-processing decisions, and model comparisons into a coherent study guide and presentation documentation dataset structure, missing data strategy, engineering features, split and scaling, and evaluating summary. The presentation emphasized the top insights, gender dominance, socioeconomic effects, VFR and class, and the age factor, alongside the best performing model, which was KNN with approximately 81.56% accuracy.
In summary, we delivered the required supervised learning pipeline with a clear pre-processing, model selection, and evaluation, while interpreting the results through both statistical measures and historical context.
This project meets the assignment's criteria for understanding, correct implementation, and clear presentation, and our teamwork combined hands-on modeling with structure.
I would like to thank my colleague Houssam for the collaboration and his insightful input, and I would like also to thank the Limitless Learning team for the opportunity for this AI Foundation and everyone else who was part of this journey.
I also want to thank you, my dear colleague Nadir, for all your hard work. And as is mentioned here in the screen, if code can confirm the past, what can it tell us about our future? I hope it will be all a good good thing. And thank you very much. Thank you. Stop.
Wait.
Okay. Stop recording.